I am Manjik Shrestha. So I have been working in Rumsan since past 4 5 years as a blockchain lead, and during that period, I have I have experience in various kinds of application in the blockchain and mostly in Ethereum space. मैले Ethereum space मा चाहिँ multiple projectsहरू lead नि गरेको छु, and there are multiple processes that I have that's ongoing to Ethereum space मा हैन. So त्यही भएर चाहिँ आज चाहिँ हामी that what I have learned throughout these years, I'm just sharing my knowledge basically. So you can see my details here. If you want to contact me, here's my email. So to start with this session, I'll just briefly walk you through आजको एजेन्डाहरू. So आज चाहिँ basically being it a blockchain session, I'll just briefly give introduction to the blockchain, and त्यसपछि we'll go through Ethereum network ko barema, how Ethereum network actually works, and त्यसपछि the most important part, smart contracts in Ethereum, कसरी smart contracts हरूले कसरी चाहिँ Ethereum-लाई चाहिँ Ethereum network-लाई चाहिँ boost गरेको छ हैन. अनि simply transaction-हरू कसरी हुन्छ Ethereum-मा, and there's a very important part called EIPs, which basically improvement proposals हरू Ethereum-को, how that works. And we'll briefly go through scalability trilemma of the blockchain and basically go through use cases. Right? So we will try to cover these topics within this webinar hours. Okay. So our blockchain I explain गर्नु पर्दा हैन. So I most of the time say so blockchain is not actually a brand new technology. It's been this technology has been since the emerging of our internet, and so it's not a brand new technology. It's just the combination of some other technologies that we already have. So other technologies, yeah, I think most of you have heard of P2P networks, right? So P2P networks has been popular by you given some torrents, right? So torrents. So I guess most of you have heard or tried torrents. It's a basic example of the P2P network, right? And there's a cryptography. I hope cryptography now in internet everywhere applies a cryptography from this HTTPS SSL that we use when you are browsing a website, त्यहाँदेखि लिएर अरु जुनसुकै application चलाउँदा चाहिँ there includes some kind of cryptography, and also a consensus mechanism, which is basically कसरी चाहिँ हामीले डिस्ट्रिब्युटेड नेटवर्कमा चाहिँ डेटाहरूलाई चाहिँ डेटाहरूलाई चाहिँ एग्रिमेन्टमा ल्याएर एउटै डेटाहरू सबै डिस्ट्रिब्युट नेटवर्कमा कसरी चाहिँ स्टोर गर्ने भन्ने कुरा हो हैन. सो दिस टेक्नोलोजी इज अलरेडी देयर, एन्ड ब्लकचेन इज or let's say it's a distributed ledger is a technology which combine all of the technology and give it to us as a package, so this technology used as a package भनेको चाहिँ I can say a distributed ledger technology or a blockchain technology, which works on top of the internet infrastructure. So to explain the blockchain लाई explain गर्नु पर्दा definition दिनु पर्दा so it's basically a P2P network of linearly connected information containing blocks, so blockमा चाहिँ informationहरु store भएको हुन्छ between a P2P network secured with a cryptography, so त्यो blockमा भएको informationहरु चाहिँ cryptography को through चाहिँ secure भएर बसेको हुन्छ. We will not dive into कसरी चाहिँ यो secure कसरी चाहिँ secure भयो हुन्छ blockमा कसरी data बसेको हुन्छ. We will not dive into that, तर it's just I'm just explaining the definition of a blockchain, and so I'm just explaining it to move it to the Ethereum, so what's Ethereum भनेर भन्छ, so a blockchain अब so it's been a hype since many years, so it's been like अहिले कति भयो, it's 15 years I guess, few blockchain introduced भएको since Bitcoin, and it has been very exciting since the introduction of the blockchain through the Bitcoin, so अब किन चाहिँ यस्तो blockchain को hype आएको त, so So I know with the digitization that we are coming through, I know this the जुन कुरा नि digitize भइरहेछ हैन. So digitization हुनुको साथसाथै we are getting some kind of हैन a limitation or some kind of flaws or one. Let's call it digitization gambit, right? So with benefit of the internet, like benefit of internet, everything is digitized. So back in the days, books or like you have to physically buy a book. See, now you can just have a digital copy of it, digital copy of music, digital copy of art, right? So you can simply with a click you can have like uh, millions of copies. We can share the copies, I know. So the digitization it's been easier, but it also comes with the flaw, when you digital content or ownership how we gonna maintain that with the digitization, I know. So anyone can copy their digital art, digital content. It won't have a value यस्तो भयो भने त हैन कसरी भ्यालु चाहिँ क्रिएट गर्ने so with blockchain we can have these we can create a value for this digital content हैन so we can create the ownership of the digital content so unique digital content कुन हो भनेर चाहिँ unique digital content create गर्न हेल्प गर्छ blockchain basically हैन so त्यो कारणले it's important in nowadays हैन blockchain लाई introduce गर्नु चाहिँ अनि सँगसँगै so blockchain ले चाहिँ पावरलाई डिस्ट्रिब्युट गराएको छ हैन अथोरिटीलाई डिस्ट्रिब्युट गराएको छ सो पहिला any platform if is controlled by a single entity or with blockchain this control can be distributed among the people among the users or अनि अरु अरु कुरा अब ब्लकचेनले चाहिँ बेसिकली ट्रस्ट चाहिँ मेन्टेन गराउँछ बिट्विन द युजर्स सो द्याट your data is secure your data is with you हैन so मान्छेले आफ्नो डेटा ओन गर्न चाहिँ ब्लकचेन हेल्प गर्छ so with all this we can term it as a web 3.0 हैन so web 3.0 मा चाहिँ web 3.0 मा चाहिँ we see most of the time ownership को कुराहरु हैन so how digital content could be owned हैन so यसमा चाहिँ भ्यालु इन्टरनेट अफ भ्यालु भन्छौँ के हैन बेसिकली वी सो ब्याक इन द डेज हाम्रो इन्टरनेट अफ इन्फर्मेसन भनेर वेब 1.0 लाई हामीले चिन्छौँ हैन अनि त्यसपछि वेब 2.0 so where people can just collaborate हैन and now people needs to transact something of value in the internet in the digital platform so त्यसको लागि चाहिँ there needs some kind of trust there needs some kind of you distributed authority or some kind of value in the digital content through which blockchain brings in. It's not just blockchain that helps to bring a web 3.0. There are other technologies like AI, there's metaverse so we are moving into that and this much blockchain is one of the part that helps to move the internet to the web 3.0 basically so just explaining why blockchain is important basically right so to explain so let's jump into the Ethereum so Ethereum is basically a public blockchain if so public blockchain like Bitcoin so I guess everyone must have heard of Bitcoin so once it has been a very huge hype Bitcoin introduced भइसकेपछि सो बिटकोइन चाहिँ किन हाइपमा आयो भन्दाखेरि चाहिँ त्यसले चाहिँ भेरी इम्पोर्टेन्ट एउटा प्रब्लम सल्भ गरेको थियो कि बेसिकली हैन सो इफ यु वान्ट टु ट्रान्ज्याक्ट अ मनी अ करेन्सी between you and some any other users you can do that transaction a digital currency you can do that transaction without any middleman Bitcoin proposed a solution how this could be get saved how without a middleman we can transact a currency भनेर चाहिँ Bitcoin ले propose गर्यो and it's with introduction of Bitcoin blockchain को technology मा exploration widely सुरु हुन थाल्यो हैन and then 2015 14 15 there comes Ethereum which is also a blockchain public blockchain त्यसले चाहिँ extra features हरु add गर्दियो के यो blockchain मा चाहिँ हैन so त्यसले अब so extra feature भन्नाले चाहिँ त्यसले basically यो Ethereum यो network मा चाहिँ smart contracts हरु लेख्न मिल्छ हैन Smart contracts भन्नाले basically a piece of code, हैन? It's basically a piece of code that could be uh, uh, executed in a network, हैन? So smart contract it's not हैन यो के भन्छ ब्लकचेन अगाडि नभएको कुरा पनि हैन. It's a digital contract नै हो नि हैन, digital contract होइन. So it could exist without a blockchain, तर ब्लकचेनमा हुँदा चाहिँ यो किन धेरै भ्यालुएबल हुन थाल्यो भने भन्दाखेरि चाहिँ त्यो इम्युटेबल हुन गयो बेसिकली हैन. So once you write a contract is basically agreement, हैन. So how a business process should work भनेर एउटा अग्रिमेन्टमा लेखेको एउटा contract, once it gets deployed in a blockchain, it cannot be changed. It gets immutable, हैन. It cannot be changed at any point of the time, हैन. So त्यो featureले गर्दाखेरि smart contract become very powerful in a blockchain. Now people can not just transact a currency, simple currency, they can code their business logic in the blockchain, okay? हैन. So blockchain-मा अब आफ्नो कुनै पनि बिजनेसमा जस्तो खालको ट्रान्ज्याक्सन हुन्छ. For example, हैन, very good example would be a supply chain को कुरामा हैन. So in a supply chain there are multiple intermediaries हैन, अनि the goods is transferred between multiple stakeholders हैन. So कसले गुड कहाँ पायो भनेर त्यो सबै कुरा ट्र्याक चाहिँ हामीले कन्ट्र्याक्टको एग्रिमेन्ट थ्रुबाट ब्लकचेनमा चाहिँ स्टोर गरेर राख्न सक्छौँ, which is immutable, which is one हैन great use cases of the blockchain हैन. सँगसँगै अब जुनै पनि बिजनेस युज केसेस जसमा चाहिँ हैन यो ट्रान्सपेरेन्सीले गर्दाखेरि इम्युटेबिलिटीले गर्दाखेरि if adds value to the business logic, we can implement blocks into that business basically हैन. So इथेरियमले चाहिँ यसलाई एक्सप्लोर गर्यो and it becomes more powerful भनौँ हैन. So इथेरियममा चाहिँ so if we have to talk about the Ethereum, हैन, इथेरियममा चाहिँ whenever you write something, you write something into a contract, or you do some you send some currency to someone, it's like changing a state of the Ethereum network, हैन. So if you see in this diagram, हैन, like any other blockchain, इथेरियमले पनि सबै आफ्नो डेटाको कपीहरू डिस्ट्रिब्युटेड वेमा चाहिँ सबै नोड्सहरुमा चाहिँ राखिरहन्छ. So every नोड्सहरुलाई चाहिँ हामी EVM भन्छौँ हैन. It's basically a server that's run the Ethereum virtual machine, हैन. Ethereum virtual machine is a piece of software that could be run in a server, हैन. सबैले चाहिँ आफ्नो EVM चलाएर चाहिँ एउटा नेटवर्क बनाएको छ बेसिकली. इट्स इथेरियम हैन, पब्लिक ब्लकचेन, एनीवन क्यान जोइन इट. सो यसमा चाहिँ कसैले केही कन्ट्र्याक्टमा बेसिकली हाम्रो स्मार्ट कन्ट्र्याक्टमा कसै डेटा राइट गरिरहेछ भने इट्स बिकम एउटा ट्रान्ज्याक्सन भन्छौँ क्या हामीले बेसिकली हैन. इट इज अ ट्रान्ज्याक्सन द्याट्स एक्जिक्युटेड इन अ पब्लिक ब्लकचेन इन अ इथेरियम. सो नाउ when the transactions happen, the state of the network changes, हैन. स्टेट अब स्टेट चेन्ज भन्नाले के हो त भन्दाखेरि बेसिकली त्यहाँको एभ्री नोडमा भएको कन्टेन्ट चेन्ज भयो नि त. सो फर एक्जाम्पल इफ एबिसी ओन्स 10 रुपिज एन्ड XYZ own 20 rupees, if ABC transact 5 rupees to the XYZ person, then balances update गर्नु पर्यो. That balance update should be executed to each and every nodes of the network, हैन. त्यो कारणले पनि we can see that whenever you do a blockchain transaction, it takes some time because it has to be executed, it has to be transferred to each and every nodes of the node of the network, हैन. So त्यसलाई चाहिँ हामी ट्रान्ज्याक्सन भन्छौँ हैन. बेसिकली चेन्जिङ द स्टेट अफ द नेटवर्क भनौँ न हैन. So transaction चाहिँ basically it's executed by the external accounts, हैन. So whoever external accounts in the sense whoever owns the Ethereum wallets or one, हैन. So walletsहरू भन्नाले चाहिँ it's a identity that that the users have. So with that wallet, they can send a transaction to the Ethereum. So it's not just an Ethereum blockchain. In any other blockchain, you should own a wallet to do a transaction. So to transaction गर्दाखेरि चाहिँ that wallet helps you to cryptographically sign एउटा specific instructionलाई चाहिँ sign गर्न चाहिँ help गर्छ भनौँ basically होइन. So त्यो instructionलाई sign गरेपछि what you can prove is that specific transaction is done by me through a wallet that I own, through identity that I own, and I do a transaction. That transaction once executed in a blockchain, it gets immutable. Now, blockchain must save voice. Now you can never deny that the blockchain to Ethereum transaction bats. It's basically same like any other blockchain. Ethereum pani transaction SR. So the important part in how the transactions executes in Ethereum is there is a concept of the gas. So gas and gas को feesहरूको concept also. So Ethereum gas भन्नाले हामी के बुझ्न सक्छौँ भन्दा it's basically a measure of computations done by the measure of the computation done by the Ethereum nodes. So यसलाई analogs to यो हामीले बाइक्सहरुमा गाडीहरुमा ग्यासोलिनहरु हाल्छौं नि पेट्रोल or डिजल ग्यासोलिनहरु हाल्छौं नि हैन त्यो ग्यासोलिनको एनालोजीमा लिदा नि हुन्छ हैन So whenever you do a transaction it obviously does some kind of computation in Ethereum nodes ma हैन some kind of computation भन्नाले के हुन सक्छ for example when you do a simple transaction like sending a currency एउटा लेजर त्यो ब्लकचेनको लेजरमा चाहिँ एक ठाउँबाट घटाएर अर्को ठाउँमा बढाउनु पर्यो हैन प्लस माइनस हुने कम्प्युटेसन कस्टहरु लाग्छ सो त्यसको लागि चाहिँ मेजर हो के बेसिकली ग्यास भनेको हैन सो एडिसन गर्नलाई फ्यु ग्यास कस्ट लाग्छ भने हैन यो मल्टिप्लिकेसन गर्नलाई अलिकति धेरै ग्यास लाग्छ हैन सो whenever you do a transaction you need to provide a gas basically to do that transaction the gas ko लागि चाहिँ how you pay for the gas you pay with the cryptocurrency हैन so in Ethereum you pay with the ether you need to pay for that specific gas in ether when you do a transaction so यसमा चाहिँ हैन so gas चाहिँ transaction गर्दाखेरि you can provide some at some limit हैन एउटा gas को पनि always there is a limit to a gas for example in bike मा पनि you cannot fill up infinite level of gasoline in your bike and there is a limit so transaction गर्दाखेरि there is some limit त्यो transaction ले त्यो limit सम्म मात्र त्यो computation गर्न सक्छ के so यो एउटा transaction मा चाहिँ you cannot send huge amount of computation in one single transaction हैन so त्यो limit मा चाहिँ we set a gas we pay for the gas fees and gas fees change based on the network को traffic को basis मा so कतिको traffic छ त्यो network मा based on that gas को fee change भइरहन्छ त्यो gas को fee लाई चाहिँ हामीले ether मा तिरेर चाहिँ transaction गर्छौं basically हैन so now once the transaction executes if there is any excess gas remaining beside the gas you send the gas चाहिँ refund नै हुन्छ basically हैन so that's how the basically transaction executes in an Ethereum blockchain not just in Ethereum in most of the chain you need to pay for the computation one so यो कारणले गर्दा चाहिँ whenever you do a transaction you have to pay some transaction fees or pay गर्नुपर्छ भन्ने भन्छ नि हैन so that's why you need to pay a transaction you're basically paying for the computations Ethereum network मा you're paying for the computation done by Ethereum network and those gas fee will be collected by the miners of that network basically हैन so जति पनि validators or miners हरु छ त्यो network मा they will collect that fees right so I think I covered basically what is Ethereum and how these transactions happen in the Ethereum, होइन. It's basically a protocol level how Ethereum works भनेर कुरा हो, होइन. So now so Ethereum चाहिँ if any updates needs to be done on the Ethereum, and Ethereum the software, it's a piece of software that runs by every node त हो नि, होइन. So त्यसमा अपडेट्सहरू गर्नु पर्यो भने चाहिँ कसरी हुन्छ त. So त्योतिर लाग्ने हो भने चाहिँ you can see these EIPs भन्ने एउटा there's a thing called EIPs in Ethereum basically, होइन. So we call it Ethereum improvement proposals-हरू. So यो भनेको के हो भन्दाखेरि basically, होइन. So यसमा चाहिँ basically Ethereum, first let's assume Ethereum is something that is managed by a community. Okay? It's not owned by anyone. Like a blockchain, blockchain cannot be owned by any single person. It's a distributed network. Same as Ethereum itself is a decentralized autonomous organization. The decision made in the Ethereum should come from the Ethereum community. So there's a thing called EIPs through which anyone can propose the improvements in the Ethereum. It could be on the protocol level, it could be on application level, it could be in how the decision making should work on the level, so any kind of proposals can be made through the EIPs, Ethereum ecosystem basically. So when you you can go through this GitHub thing, so GitHub saying there's a Ethereum GitHub, which is managed by a community, so you can basically if you have any kind of valid proposals how the Ethereum should work, you can write up the proposals and submit the pull request to that specific GitHub repo. So it's basically there will be monthly calls reviews with the existing Ethereum community bichma, so anyone can also review the EIP improvement proposals, so monthly calls सबैजना meetingsहरू बसेर, so they basically review if it's a valid proposal, if this proposal gonna improve the Ethereum ecosystem. त्यो हिसाबले चाहिँ there are multiple steps, and once it finalizes, that will be implemented. If it's an application level, it is implemented at application level. It's a protocol level, it gets implemented in the protocol level. त्यो अनुसारले चाहिँ डेभलपमेन्ट्सहरू चाहिँ भइरहेछ Ethereum, basically Ethereum space-मा, हैन. So EIPs-हरू, there are different types of EIPs, so most of the popular one is standard tracks or EIPs, so it basically divided into three standard track one, so meta track or informational track, and the standard track is the most common one. Meta track one, it's basically any proposals beside the Ethereum protocol बाहेकको improvement proposals or meta. So basically it could include things like how the Ethereum how the EIP should be designed, so EIP चाहिँ को format यस्तो हुनुपर्छ भनेर पनि proposal गर्न लगिन्छ. So that comes with the meta track को EIPs हरुमा, so there's informational EIPs हरु. So informational भन्नाले it's basically it's not needs to be implemented, it's just the providing information to the Ethereum system if there are any serious possible attacks that could hamper the Ethereum भनेपछि त्यो attack-लाई चाहिँ document गरेर there are such kind of design issues भनेर highlight गरेर documents-हरु submit गर्छ, and such documents are the informational EIPs, so it can be basic guidelines or how Ethereum should how this smart contract should be written, basic guidelines or informational. These informational EIP is not so important, it could be followed, it might not be followed, and as I said, the most important part is standard track EIPs, so standard track EIPs there are त्यहाँ पनि multiple categories छुट्याएको छ. core protocol-मा changes-हरु गर्नु छ भने, so core protocol-मा changes includes हाम्रो EVM machine-मै how the EVM machine should work भनेर core protocol-मा changes-हरु हुन सक्छ, So networking level, how the consensus algorithm should work, होइन? So how the each EVM should network in this Ethereum ecosystem, होइन? इन्टरफेसको लेभलमा. सो इभिएमहरूमा कस्तो खालको चाहिँ एपिआइजहरू चाहिँ एभाइलेबल हुनुपर्छ, होइन? सो कस्तो खालको एपिआइजहरूको थ्रुबाट चाहिँ ट्रान्जेक्सन हुनुपर्छ, त्यो खालको इन्टरफेस लेभलको हुनसक्छ. अनि अर्को भनेको ERCs भनेर छ, विच इज बेसिकली एप्लिकेसन लेभलमा बनाउने स्ट्यान्डर्ड्सहरू हो, होइन? सो त्यसलाई एक्सप्लेन गर्नुपर्दा इट्स बेसिकली इथेरियम रिक्वेस्ट फर कमेन्ट्स हो. आई हेभ सेपरेट स्लाइड फर द्याट, होइन? सो दिस ERCs इज मोस्ट कमन एन्ड होइन धेरै प्रपोजल आउने EIP हो बेसिकली, होइन? सो ERC भन्नाले इट्स अ टाइप अफ EIP नै हो, एप्लिकेसन लेभलमा स्ट्यान्डर्ड्स हो, होइन? सो इथेरियम कम्युनिटीले मानेको स्ट्यान्डर्ड हो बेसिकली, होइन? दिस स्ट्यान्डर्ड कुड बी फलोड, माइट नट बी फलो, होइन? तर फलो गर्यो भने चाहिँ इट्स बेटर, होइन? तर समथिङ लाइक कोर नेटवर्किङ लेभलमा, इन्टरफेस लेभलमा भएको EIPs भने द्याट सुड बी फलो, बिकज इफ इट्स नट फलोड, दिस इथेरियम नेटवर्क माइट नट वर्क एज एक्सपेक्टेड, होइन? सो कोर लेभलमा फर इक्जाम्पल रिसेन्टली त होइन, इट्स बिन लाइक 1.5 years or 2 years, होइन? सो इथेरियम प्रुफ अफ वर्कबाट प्रुफ अफ स्टेकमा सरेको थियो. इट्स अ कोर प्रोटोकल लेभलमै चेन्जेस हो नि त, होइन? सो दोज चेन्जेस should be implemented by all the existing, होइन, इथेरियम नोडको अपरेटर्सहरू के, होइन? सो त्यस्तो खालको EIPsहरू चाहिँ सबैले मान्नै पर्यो. अनि देयर इज एप्लिकेसन लेभलको स्ट्यान्डर्ड छ, which could be implemented by most of the application and could not be, नगरे पनि that's not a problem, होइन? तर त्यो गऱ्यो भने चाहिँ इट्स बेटर फर द इथेरियम कम्युनिटी. सो यस्तो खालको होइन EIPsहरू चाहिँ मोस्टली यो कन्ट्र्याक्ट र टोकन स्ट्यान्डर्ड्सहरूमा छ, होइन? सो पपुलर ERCsहरू भन्दाखेरि देयर इज ERC20, होइन, विच इज द मोस्ट पपुलर वान. इट्स बेसिकली टोकनको स्ट्यान्डर्ड, ओके, फन्जिबल टोकन स्ट्यान्डर्ड. अन टप अफ इथेरियम पनि इफ यु वान्ट टु क्रिएट अ सेपरेट टोकन्स, त्यो टोकन्सहरू चाहिँ कसरी क्रिएट गर्न सकिन्छ भनेपछि ERC20 भयो. सो with this token standard, there has been a lot of development in the DeFi sector, होइन? सबैले यही स्ट्यान्डर्ड युज गर्न सक्यो. सो एभ्रीवान नोज टोकन्सहरूको इन्टरफेसहरू कस्तो कस्तो हुन्छ भनेर बेसिकली, होइन? And basically there's ERC 721 भन्ने स्ट्यान्डर्ड छ, which basically nowadays we know it as NFTsहरू and non-fungible token standardsहरू. And there's another popular ERCs, होइन, ERC 1155 छ, which is a multi-token standard. So यसले चाहिँ एउटा कन्ट्र्याक्टको थ्रुबाट चाहिँ how we can create multiple type of tokens and manage those multiple type of tokens भनेर. It's not just ERC20, ERC20 one type of token भयो, we can create multiple types of token through ERC 1155. So यो खालको टोकन स्ट्यान्डर्ड चाहिँ मोस्ट popular on the गेमिङ सेक्टरमा भनौँ न, होइन? गेमिङ सेक्टरमा इफ यु सी देयर्स, होइन, सो देयर्स लाइक कोइन्स, देयर रिवार्ड्सहरू हुन्छ नि त, होइन? सो इफ यु गो थ्रु लाइक पपुलर गेम्स लाइक पब्जीहरू, यिनीहरू चाहिँ देयर्स त्यहाँ पनि भित्र आफ्नै कोइन्सहरू हुन्छ नि त, होइन? देयर आर मल्टिपल टाइप्स अफ कोइन्सहरू हुनसक्छ. त्यस्तो लेभलमा चाहिँ वी क्यान युज दिस ERC 1155 टोकन्सहरू. अनि देयर इज नट जस्ट टोकन स्ट्यान्डर्ड, देयर इज लाइक EIP 712, होइन, विच इज बेसिकली कसरी चाहिँ मेसेजहरू साइन गर्नुपर्छ. इफ यु वान्ट टु साइन एनी मेसेजेस इन इथेरियम, हाउ द मेसेजेस सुड बी साइन भनेर इट्स अ EIP 712 स्ट्यान्डर्ड. सो these are the basically few popular ERCs, होइन, that I have listed out, and you can go through the GitHub reposहरूमा EIP. There are tons of improvement proposals that's been finalized, that's always in draft, and if you want to review, we can also go through that EIPs again, basically. So okay, I think I saw some questions, but I think I'll later go on through that question, right? So next, so this is basically about the Ethereum, I know how the Ethereum ecosystem actually works. Now I think we have covered how Ethereum works, what's the important features of Ethereum, and how the improvements in the Ethereum works. Now, there's a very I know widely talked topics so scalability trilemma, not just in Ethereum, wide along the blockchain, I know. So blockchain implement गर्दाखेरि चाहिँ there's it's like something like a cap theorem. There's a trilemma you have to choose in between, I know, between a security, decentralization, and scalability. You cannot have all three of them at once in a blockchain network. You have to choose, you have to let go one of them and choose one of them, choose two of them basically, you know. So अहिले Ethereum, Bitcoin case गर्नुपर्दाखेरि they choose decentralization and security over the scalability of the network, you know. So if you see on the Bitcoin and Ethereum, when you do a transactions, it's not uh, it's not that fast, I know. I mean, it's not it's get expensive as the time goes by basically Ethereum, होइन. So त्यो भएर पनि most of the business लजिकहरूलाई डाइरेक्टली इथेरियममा बिटकोइनमा ल्याउन चाहिँ गाह्रो छ कि. सो त्यो स्केलेबिलिटी इस्युजहरू चाहिँ छ. सो त्यसैको लागि भनेर देयर आर अदर चेन्सहरू, भी चेन, आयोताहरू, which basically focus decentralization and scalability. And similarly, there's different chains or route that focuses on security and scalability instead of the decentralization. You know? So it's very hard to, I know, it's a trilemma that we see in the blockchain space. Okay, so what tree you want to choose? Would choose one, you know, basically, you know. So you have to choose two between these three, basically. सो यसैको लागि हेरेर होइन स्केलेबिलिटी अब इथेरियममा एज आई विथ दिस ट्रिलेमा देयर इज ए भेरी ह्युज ग्याप इन द स्केलेबिलिटी, होइन. अब त्यसलाई मेन्टेन गर्न how the Ethereum is working on to manage the scalability problem भनेर हेर्दाखेरि there's a layer 2 scaling solutions-हरु, होइन. So layer 2 भन्नाले it's as a name says के भन्दा it's a layer that executes on top of the base layer. So base layer there could be Bitcoin, there could be Ethereum, popular ones, and on the layer 2 there are other networks or other softwares that work on to scale the solutions. So Bitcoin case there is a thing called Lightning Network, I know. So Bitcoin transaction it gets really slow, I know. The slow भएको कारणले, so there's a thing called Lightning Network, so which basically executes the most of the transaction off chain, right? So for example, between group of people, ABCD, right? Between group of people, if they have to do bunch of transaction, they do the transaction within a Lightning Network, bunch of transaction गर्छन्, होइन. And at the end, final balanceहरू जति हुन्छ त्यो final balance मात्र बिटकोइन नेटवर्कमा अपडेट गर्छन् के, होइन. So it's basically a state channel concept हो, होइन. So roughly बुझाउनु पर्दा it's basically how it works, होइन. So layer 2 scaling छ र यसरी नै अफ चेनमा चाहिँ मोस्ट अफ द टाइम चाहिँ अफ चेनमा चाहिँ डेटा प्रोसेस गरेर चाहिँ अनि एट द एन्ड रिजल्ट्सहरू मात्र बेस प्रोटोकलमा अपडेट गरेर चाहिँ काम गर्छ, होइन, लेयर 2 स्केलिङ सोल्युसन. सो देयर इज अ प्लाज्मा विच बेसिकली हेल्प्स टु क्रिएट अ साइड चेन्सहरू. लेयर 1 सँगसँगै अर्को एउटा सेपरेट ब्लक चेन क्रिएट गर्ने हो साइड चेन भन्नाले. त्यो ब्लक चेनमा चाहिँ ट्रान्जेक्सन गर्ने एट सम अनि एट सर्टेन पोइन्ट अफ टाइममा मात्र त्यहाँ भएको अपडेट्सहरूलाई चाहिँ लेयर 1 स्केलिङ सोल्युसनमा अपडेट गर्ने. Basically, it's a side chain of the layer 2 scaling solution, होइन. So त्यसको popular example भनेको you can see Polygon network, होइन, इथेरियमको स्पेसमा. So there are multiple layer 2 scaling solution. It's just not just side chainहरू मात्र होइन, होइन. So there are rollups-हरू भन्ने अहिले आजकल धेरै popular छ, होइन, इथेरियममा. So rollups is basically as a name suggests, होइन. So bunch of transactionलाई चाहिँ रोलअप गरेर एउटा सिम्पल ट्रान्जेक्सनमा चाहिँ मेन चेनमा चाहिँ अपडेट गरिदिने हो. सो जीके रोलअप्सहरूको कन्सेप्ट छ. इट्स बेसिकली जिरो नलेज प्रुफ भन्छौँ, होइन. न देयर हेज बिन अ ह्युज रिसर्च डेभलपमेन्ट्सहरू भएको छ जिरो नलेज प्रुफमा. इट्स बेसिकली zero knowledge भन्नाले अब बेसिकली एक्सप्लेन गरौँ न, इट्स बेसिकली proving that होइन. सो कुनै पनि स्पेसिफिक कन्टेन्ट चाहिँ एक्जिस्ट गर्छ without actually revealing that content, okay, होइन. So without actually revealing the content, you prove that that content exists, होइन. So such kind of concepts हरू छ होइन, GK rules through which we can process the data off chain and only update the data होइन at the end of the process on the layer 1 solution through which it brings होइन ट्रान्जेक्सनहरू फास्टर गराउन चाहिँ हेल्प गर्छ भनौँ न होइन. So these are a few layer 2 scaling solution. It's a very everyone has their own pros and cons, I know. So I don't think we can go through all of this, but just for the information, I know you can go through these slides and you can have your own research. If any queries, I think we can talk after this session too. Okay, so let's quickly dive into the use cases होइन. So blockchain blockchain or Ethereum spaces होइन. So use cases को कुरा गर्दा firstly I'll definitely give best use cases of blockchain has been a decentralized finance, DeFi भन्छौँ होइन. So DeFi is basically होइन अहिले जति पनि हाम्रो ब्याङ्किङ ट्रान्जेक्सनमा जस्तो खालको पनि ट्रान्जेक्सन हुनसक्छ, लाइक लेन्डिङ, बोरोइङ, गिभिङ इन्ट्रेस्ट, पेइङ इन्ट्रेस्ट होइन. सो त्यस्तो सबै कुरालाई चाहिँ विदाउट एनी मिडल म्यान हाउ ब्लकचेन क्यान एक्जिक्युट दिस सच काइन्ड अफ ट्रान्जेक्सनहरू भन्नलाई चाहिँ हामी डिसेन्ट्रलाइज फाइनेन्स भन्छौँ होइन. सो थ्रु डिफाई there has been huge development in the blockchain sector, होइन. So किनभने money is involved in it, होइन. So since money is involved, everyone is interested, and there has been a huge development. It's one of the best use cases that blockchain can have. So not just DeFi, there can be multiple or any other use cases पनि होइन, like data marketplaces NFTs back in 2021 or 22 it's been a huge boom होइन. NFTsहरूको डिजिटल कन्टेन्टहरूलाई चाहिँ कसरी चाहिँ हामीले सेल गर्न सकिन्छौँ, लाइक ओनरसिप देखाउन सकिन्छौँ. अनि बिसाइड द्याट देयर कपिराइट्सहरूको लागि, लजिस्टिक्सकोहरूका लागि होइन, सप्लाई चेन मेन्टेन गर्नको लागि, रियल स्टेटको डेटा मेन्टेन गर्नको लागि, इन्सुरेन्सको लागि, हेल्थ केयरमा अब डेटा इन्टिग्रिटी डेटालाई सेक्योर गर्नको लागि होइन, bunch of things like he use on us. There are bunch of use cases for all of these things, होइन. So I'll just like to walk you through few examples that we have built in Rumsan, होइन. So there's application software that we have called Certify, which basically helps institutional organization to issue the certificates भनौँ न basically होइन. So यसले चाहिँ blockchain based certificate issue गर्छ so that there is a proof of existence after 10 years, after 20 years, that the certificate was issued at that point of time. So once it's issued on blockchain, no one can deny it, होइन. So that certificate, even the organization get closed, it remains in the blockchain भनौँ न होइन. So that's a certificate that we are working that we have worked on, होइन. अनि next going to the next, होइन. So this is one of the होइन like star product of the Rumsan नि भन्दा हुन्छ होइन. So राहत. So back in the days यो concept चाहिँ basically हामीले यो 8 distribution गर्दाखेरि होइन. So there is no transparency while distributing 8K. So back in COVID को बेलामा, back in यो disaster को यो earthquake को बेलामा होइन. So राहतहरू आए तन्नै बाहिरबाट, and कसैलाई there is no proper way to show everyone कि distribution कहाँबाट beneficiary पुग्यो कि पुगेन, to track all this distribution होइन. So त्यो प्रब्लमलाई चाहिँ बुझेर चाहिँ we try to create this protocol through which we can track all of these distribution process through a block with the help of the blockchain network. So this is basically one of the use cases that we can have through blockchain. And there's a supply chain, obviously, so there's a product called AgriClear. So whenever agri products are आउँदाखेरि you don't know कि त्यो agri products are कहाँबाट आएको हो. So they claim that it's a मुस्ताङको स्याउ, it's मुदीको आलु हैन, मुदेको आलु. So there's no digital record to prove that it's actually the claim is valid भनेर हैन, त्यहीबाट आएको भनेर. So AgriClear product ले चाहिँ basically supply chain लाई track गर्न help गर्छ हैन. So every agri products हरु farm देखि आफ्नो प्लेटसम्म आउँदाखेरि कुन process को थ्रु चाहिँ गयो भनेर सबै डेटा लाई चाहिँ track गरेर blockchain throughबाट, and we can just view the whole life cycle of that product through a scan of the QR code हैन. So त्यसरी चाहिँ हाम्रो blockchain चाहिँ implement गर्न लाग्छौँ. So you यस्तो खालको use case मा one of the most, I know, before you ask question, one of the most questions that I get is हैन, so यसमा wrong data हामीले introduce गर्यो भने के हुन्छ त हैन. So मैले अगाडि फार्मरले राख्ने बेला wrong data राख्यो भने के हुन्छ त हैन. So त्यो केसमा so wrong data राख्यो भने you will get the garbage data. So it's blockchain is basically garbage in garbage out नै हो हैन. So त्यो भएर चाहिँ, so these kind of work will make sense when we have the proper use case of the IoT devices or internet IoT devices or हैन. So कुनै पनि agri products को temperature कति छ भनेर कति temperature मा चाहिँ हुर्काएको भनेर त्यो IoT devices हरुले blockchain मा इनपुट गर्न सक्यो भने चाहिँ there is no human interference हैन, human error हरु कम हुन्छ. So त्यो भएर चाहिँ यसलाई ट्रस्ट गर्न अलि बढी ट्रस्ट गर्न सकिन्छ हैन. So blockchain को स्पेसमा everyone have identity हैन. It's not just human, it's any IoT devices, it's any input devices, devices that can input data can have identity basically, right? Okay, so yeah, these are basically a few use cases, I know. And that's all for the आजको सेसनमा. So